Hello friends, in this video I am going to discuss one numerical which is related to concept of centroid and center of gravity. So let's start the discussion over the numerical which is related to concept of centroid and center of gravity. And here is the numerical. We have this figure, L-shaped, and for this particular diagram, we have to determine the centroid. For this particular figure, we have to determine the centroid. It is given here, determine the centroid of the given figure. And centroid, we know, it is related to plane area and volume. We don't consider any mass or weight when we are applying the concept of centroid. So here we have this particular section or this particular lamina, and we have this particular lamina is asymmetrical lamina. So we have to find out the value of centroid. And as we know, as I told you, if we find out the centroid for a particular lamina and if it is symmetrical, so at midpoint we generally consider the centroid location. But if the lamina is not at all symmetrical, so it is not necessary to locate the centroid at the center point only, or the point which is acting at the particular plane which is dividing that particular lamina in two different parts. So here we can apply the concept of the centroid where we can find out the centroid somewhere outside of the lamina also. The centroid concentration point can also act outside of the lamina. So here we have this particular lamina which is not at all symmetrical. Here if we divide from the x-axis, so this particular lamina is not symmetrical, and if we divide this lamina from y-axis, so this particular lamina is not symmetrical. So we can say the centroid can be act somewhere outside of the lamina. So here we can locate the position of centroid on the basis of coordinate points, and the coordinate points can be x bar and y bar. So this x bar distance we generally consider from the y axis, and y bar distance we will consider from the x axis. So along the y axis and along the x axis we will find out the coordinate points, and then we will locate the value or locate the position of centroid. So let's start the solution for this particular lamina. So here we have this particular lamina. Here we are dividing this lamina into two rectangles. Here if we draw a line here, you can see here this line, this dash line, and this particular dash line is dividing this lamina into two rectangles. So here we are considering this particular rectangle as, here we are dividing this particular lamina into two rectangles, A, B, C, H and D, E, F, H. So here the rectangles are and we will find out the coordinate points according to these two different sections or these two different rectangles. So let's draw the coordinate point for the centroid. So this is our lamina, and here we are taking the position of centroid at point G. Let us consider this is the position of centroid. This G is representing the position or location of centroid on the basis of this particular rectangular lamina ABCH and DEFH. And here we will mark the coordinate point from the x-axis and from the y-axis. So let us consider this particular AB as the reference and AF as the reference. So AB we are taking the reference from the x-axis and AF we are taking the reference as per the y-axis, and from this particular point we are taking the coordinate points. This point A we are taking as the base point or the reference point, and from this point we will find out the value of the coordinate point. So this x bar is taken as the coordinate or one of the coordinate of point G, and here this y bar is represented as another coordinate of point G, and this particular y bar we are taking from the x-axis, and x bar we are taking the coordinate point from the y-axis, and we have to find out these two coordinate points x bar and y bar with the help of the coordinate points of the CG of these two different rectangular lamina ABCH and DEFH. So we will find out the position of centroid for these particular laminas, and then we will find out the common centroid for this particular L-shaped lamina. So let's start the solution. So here we are taking the position of point G is at x bar and y bar. So this G is considered as the centroid of this lamina. Now let's consider different rectangle, and let's consider the reference as AB and AF. And this point A we are considering as the reference point, and the coordinate at point A we are taking as 0, 0 coordinate, and from this particular point A only we are going to find out the values of the coordinate. So let's find out the CG for the first rectangle ABCH. So if we see the rectangle ABCH, here you can see the rectangle ABCH. So in this rectangle ABCH, we are taking area is A1, and the position of CG we will find out on the basis of different coordinate points. So let's draw the ABCH. So the area of this rectangle we are taking as A1. So first of all, we will find out the area, and area we will find out on the basis of dimensions. So the dimensions are given here. You can see in this particular diagram 70 mm we are taking as the length and 10 mm we are taking as the width. So the total area for this rectangle will be 700 mm square. Here we have 70 as the length and 10 is the width, so it will be 70 into 10, so it will be 700 mm square. So we have the area of the rectangle ABCH. Now here I have marked here the x1 and y1. I have marked x1 and y1 as the coordinate point for the centroid of this rectangle ABCH. So first of all, we have to find out these coordinates. So we will find out the coordinate x1 first. So x1 we are taking from the reference or the base point, that is A, we are taking the coordinates 0, 0. So here the value of x1 will be 70 divided by 2. So it will be 35 mm. Now we have to find out another coordinate, that is y1. So this y1 we can find out by this 10 mm divided by 2, because as per the rectangle concept or the centroid of the rectangle, we can find out the value of centroid for the rectangle by dimension divided by 2. So here if we are going to find out the value of x1, so the dimension in x direction divided by 2 will be the value of coordinate x, and the dimension along the y-axis divided by 2, that will be the coordinate point along y-axis. So it will be x1 will be 35 mm, and if we want to find out y1, so the y1 will be So here we have both the values x1 and y1 for the rectangle ABCH. Now let's find out the centroid for the second rectangle. And here we have the second rectangle, that is DEFH, and here the DEFH will be with this particular dimension. Here we have to minus this 10 mm from this particular lamina. So Here the 100 mm is the total height of this lamina. So this 100 minus 10 will be the height of this particular rectangle, and this particular width is already given, that is 15 mm. So we will use these dimensions to find out the value of CG for this particular rectangle DEFH. So this is our rectangle HDEF or DEFH, and here we will find out the location of centroid for this particular rectangle. And if we are marking this particular centroid as G2, here for this first rectangle, let us consider the position of G1 is, or G1 is considered as a centroid. So X1 and Y1 are the coordinate for the centroid G1. And if we are taking rectangle 2, so the position of G2, we have to find out the coordinate points X2 and Y2. And if we are taking the area of the rectangle as A2, so the area we can find out with the dimensions. So here, as I told you, we will only consider this particular area. So here the dimension will be 100 minus 10, so it will be 90, and the width we have 15 mm for this rectangle, so it will be 15. So 90 into 15, it will be 1350 mm square. Now we have the area. Now we have to find out the coordinate points for this particular rectangle. So we will find out the value of X2 and Y2. Now the X2 value we will consider from the y-axis. So it will be, here we have the y-axis along this particular line. So the X2 value will be 15 divided by 2 only. This is the value of 15. So the value of X2 is 15 divided by 2, that is 7.5 mm. Now we have to find out the value of Y2. So it will be, so here I am taking the point A. The point A is somewhere here. So point A is the reference point and the line AB is the reference line. So we have to consider this Y2 from this particular end only. And here we are taking X2 value from this particular end. So this is just passing through point A only. So 15 divided by 2 will be the value of X2. But if we want to find out the value of Y2, so it will be 10 plus 90 by 2. So the value of Y2 will be 55 mm. 10 plus 90 by 2, so it will be 55 mm. Now we have both the values X2, Y2 and X1, Y1. So we can find out the value of X bar and Y bar by the formulas. So to find out the value of X bar, we have the formula, that is A1X1 plus A2X2 divided by A1 plus A2. This we can find out by the equation, that is summation of AX divided by summation of A. So this is representing the X coordinate, and here we will put all the values of A1 and X1, A2 and X2 and A1 and A2 here, and then we will find out the value of X bar. So this will be our equation. It will be 700 into 35 plus 1350 into 7.5 divided by 700 plus 1350. So the final value of X bar is, it will be 16.8 mm. Now we have the value of X bar. Similarly, we can find out the value of Y bar. So the equation for Y bar will be A1 Y1 plus A2 Y2 divided by A1 plus A2. So the equation will be, this will be our value of Y bar. It will be 700 into 5 plus 1350 into 55. We have all the values of X1, Y1, X2, Y2, A1, A2. So we are putting all these values here. So the equation is 700 into 5 plus 1350 into 55 divided by 700 plus 1350. And the final value of Y bar is 37.9 mm. So here we have the value of y bar and we have the value of x bar. So we will locate the position of CG on the basis of these two coordinates x bar and y bar. So these are the coordinate for the point G. It is x bar is 16.8 and 37.9 is the y bar. So we can locate the CG on the basis of these coordinate points, and the CG will be, this is the position of point G. So here on point G, we can consider this x bar distance as 16.8 mm and this y bar distance is 37.9 mm. So on that basis, we can define this particular position of centroid. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.